don't know where I cut off last, but I also realized partway through that I made a mistake. So let's fix that mistake. So say we wanted to look at this here. The radius actually is going to be, I have the radius and the height here flipped. So the radius should actually be equal to y. Essentially, think of it as being our distance from the y-axis here is going to be our radius, which means that our circumference is going to end up being 2 pi y. Now our height is going to come from figuring out the distance from the top part to the bottom part. So this here is the height. And so normally we would have the entire height of 1 to worry about, but we're taking away whatever y squared is here. So that means 1 minus y squared will be our height. The funny thing is that when we look at the volume formula, it doesn't change too much in the end from this mistake. So our volume is actually going to be equal to the integral from 0 to 1 of 2 pi y times 1 minus y squared dy. Now notice that in the end, making that mistake between which one was the radius and which one was the height didn't actually change what the final formula was, but it does. We do want to make sure we're understanding how we're getting these things. So the radius here is your distance from your axis of rotation to where you're going to. In this case, it's just y. And your height then is going to be how tall each of these are. Because essentially we've got each of these is going to be some sort of shell with a radius here, and it'll have whatever this height is. So I just want to make sure we understood where that was coming from. And it was also good to double check to make sure I didn't post it incorrectly for the notes. Alright, so all this then leads us to, we've got all these different methods for finding volumes. How do we know which one to use when? Well, there are a couple of guidelines we can use for this. There's a couple of things we want to take into account. First, is the region more easily described by some top and bottom boundary curves from y equals f of x, or left and right boundaries x equals g of y? Which choice is easier to work with? We also want to know, are the limits of integration easier to find for one variable versus the other? So we want to use disks and washers when the cross sections are perpendicular to the line of rotation. So here, if we want to rotate about a horizontal line, then we will use vertical cross sections. I can't spell either. Vertical cross sections. And integrate with respect to x. However, if we're rotating about a vertical line, then that means we are going to have horizontal cross sections and we should integrate with respect to radius, or sometimes just an outer radius, or just a single radius, and using pi r squared. Other times we want to use these cylindrical shells, and that's when we want to have cross sections that are parallel to the line of rotation. So here with these discs and with these washers, we're essentially taking a bunch of shapes like this to find our volume. When we're dealing with cylinders, what we're instead doing is we're taking and making these outside shapes that are getting kind of pieced together. So it looks something a little more like this. We've got them kind of like nesting dolls, almost. So here, when we're looking at, so this is kind of like pancakes stacked together. These other ones are kind of like nesting dolls. Here, if we want to go ahead and use cylindrical shells and rotate about a horizontal line, then here what we're doing is we're looking at horizontal cross sections. And here we integrate with respect to y. And if we're rotating about a vertical line, then you'll want to use vertical cross sections and integrate with respect to x. Alright, so all that was a lot of writing. Again, what does it mean? Well, what it means is that, say we wanted to rotate around this vertical line here. When we're making our pancakes, essentially then all of our radii will come from having some value in terms of y instead, right? So we find the example we had used from before. Say we wanted to look at example 6 from when we were using our discs and washers. Here we had some vertical line we were going around, and when we went around this, when we wanted to find our radii, they were then in terms of y. But when we wanted to go ahead and go around a horizontal line, everything was in terms of x. Now the exact opposite is true when we've been looking at things in terms of cylinders. Say we wanted to go around a vertical line, well then our radius here is considered x, and so everything else ends up being in terms of x. But when we wanted to go around a horizontal line, here our radius was in terms of y, and we wanted to do things with respect to y. So going through and figuring out first which method to use, but then figuring out how you want to write things with respect to your variable is very complicated. What I would recommend for good practice would be to try to use both methods if possible on every problem, set them up, and then make sure you get the same final answer at the end. It'll take a little bit of practice, and I definitely encourage you guys to try finding different regions for you guys to rotate around some different axis and practice on the discussion boards just setting up these integration bounds.